Welcome back, C++ code lovers. Continue our sessions of C++ programming. Hope now you're getting to love and understand or at least whatever this is. And yesterday we talked about, or whichever day you watched this, anyways, we talked about constructors and how they have different ways of defining them. So you see, I have two functions with the same name, just different set of parameters. That's called arguments, of course. That's called function overloading, right? Yeah, you can do that for all functions, not just constructors. And we're going to see that in the object-oriented course. You can do it for class functions. It's called polymorphism. This leads us to the topic for the day. Today we're going to be talking about inheritance, right? So what is inheritance? So it's just basically what it is. I mean, I was born, I inherited my father's genes, my mother's genes also, but I have characteristics my father had. So imagine you've made an object here called an animal, but this is too general. If you want to inherit different other animals from this animal class, right? Or maybe you make an object called human, and then you want to make different types of human objects. Maybe one would be I don't know, maybe by race, African, Indian, or whatever, differences in color, and maybe also the language you speak, right? So that's part about inheritance. So you're making a class, called a child class, from a parent class. Let's see how that goes. So I'm making you a file, and I'll call it inheritance.cpp. Alright, there goes. Now don't forget to include IO stream. You can include lots of other stuff if you want. You can include lots of other libraries, even your own made header files. We saw how to do that. So there you go, using num specificity. I'm just going to make a class, so call it animal. So class animal. And in this class, I'm going to have only one constructor. Now let's say, um, what do I have an animal? So I have private member fields and I have public member fields. Okay, these are mostly going to be functions, although you can still put helper functions and a private. So it's just meant to work within the class, but never to be called outside the class. I'm just going to make them variable in a sense. String, let's say, what should I say? I think kingdom and string the edge and string the kind of food it eats. And let's say I'm making a game. It's a game for animals, maybe Angry Birds, but Angry Birds only has birds anyways. But yeah, I'm going to make a constructor. So I'm going to make an animal constructor. This is going to have string kingdom and string. I think edge should be an integer, int edge and string food. Right. That's going to force me to change one thing here. I'm just going to say enter. And for everything else, I'm going to say. Remember, we talked about this keyword in our previous video. I'm just going to say this kingdom is equal to kingdom. I forget your semicolon unless you're doing Python. So this edge is going to be equal to edge, and this food is going to be equal to food. I can make all sorts of methods in here, getters and setters if I want, but I've already made a constructor anyways. This is not a default constructor, so meaning I'm not going to be able to make an object of animal without using this kind of constructor. Alright, so again, the constructor is just a function which gets called automatically when you create an object. This is the first function which gets called. Yes, so it just allocates this space for this object, meaning the variable is going to store here. So for string, for this string is integer and that string, and of course the space also for the functions, not so much space anyways. It's arguable that functions even get any space in the RAM, at least the declarations anyways. But yeah, so it's going to reserve space for this object. How big this object is a combination of how big the member variables are. So here we go, I'm just going to make a small function is going to be void print all, and this is going to print what we have. So this is going to say see out the kingdom. Let me do this and see out the edge. Oh no, goodness me. And see out the food. Let me see. I call food or that. Alright, whatever I call it. Food. To make it a bit more natural to read, I think I'd like to put semicolons or full colons rather. Sorry for that. I'm just going to put full colon there and full colon there and full colon there. So there is a class called animal. Now this class can be inherited. I can make another object which has all the properties of this animal. Remember, I have my father's genes, so I have all his genes. Maybe also I can add on my own features. I may have higher. The genetic model doesn't fit so much because I have exactly the same genes as my father did. Or if a few differences here and there, but you can think of inheritance, something like that. Anyways, so we'll say, we'll make another class. I'll call it class, and I'll say dog. A dog is going to be inheriting from animal. And that's how you do it. Although you say public. Cool. So this means, don't forget to semicolon there. So to inherit in C++, use a full colon. So you make a class, the child class, then full colon is inheriting from the parent class, right? And in languages like Java, it can be different. For example, in Java, you say, I'd say something like this, public class dog extends animal, right? Then I'd go on with whatever I'm doing. That's how you'd say it in Java. But then in C++, it's a bit different. Well, the concept was the same anyways. But then in Java, you have to use the keyword extends. In C++, you just use a full colon, you are done, and you forget about it. So you can make your own variables in here. You can make them private or whatever. And if you had protected members here, guess you have protected. So these can be accessed anywhere else but from the inherited class or inheriting classes. Yes. Yeah, so protected. This can be, I don't know, do animals have bank accounts? No, they don't. Or do they have relatives? I doubt they do. Or can you make protected, which is a characteristic of most animals. Let's say, do they have children? Yeah, but they don't care much about them. Let's say string habitats. Well, all of them have to live somewhere anyways. Okay, no, habitat. Now this, it's a method of animal class. You can initialize it if you want to. You can leave it like that, but it's projected, meaning it can be accessed by objects of dog class. Okay, and you can also specify what kind of variables you want it to inherit. So you can say protected animal that's discouraged, or private animal you want it to inherit private member variables. You're gonna have problems with that, so mostly just use public because you want to inherit all these things at a public, meaning you're inheriting all these things at a public, right? And it's going to have the same things here. So you can make your own private things. Let's say private variables. Let's say string. I don't know those species. Maybe I'd like to give it a name. And public, we can go a constructor. It's going to be dog, and it's going to have string kingdom int age string food, and string species string name. Okay, that's if you want. I can literally say can call animal and then supply kingdom, age, and food as arguments, because this is a child class. It's inheriting from the parent class. Okay, am I missing something here? Anyways, forget the shortcut. Let's just make our own constructor. Just start on constructor. Oh, and if I'm inheriting, I'd like to put the default constructor also. I'm just going to say animal and default. I'm just going to say set the kingdom to now and everything else to now. The age to 0 and the food to now. Remember that's a string, right? Alright, there goes. Now we come to this. So calling the dog constructor, it automatically creates an object of animal class. So you can say animal. Then you provide kingdom. What am I missing? Kingdom, age, and food. Right. Calling the parent class. And then whatever else is not set, you can say species. This species is equal to species, and this name is equal to name. Okay. Now I'm not going to create any member fields in here. I'm going to create any member functions, and we're going to have access to this print all because it's an object of animal. Let's see how that means. I'm just going to make int main, and I'm going to make two objects. One is going to be my animal object. I'll call it animal one. Let's say it's a vertebrate. That's a kingdom. It's about 11 years old, and it eats. Wow, it's flesh. Alright, I'm going to make a dog. I'll call it my dog. Dog object, and to this will supply the same things as supply. So a dog is also a vertebrate. The same dog is about 2 years old, and it eats, I don't know, chicken. Its species, I don't know about that. I think it's called it. I'm not sure. It's not a biology class. And the name, I'll call my dog Husky. Siberian Husky. Alright, so I have those two fields. I'm going to say animal one dot print all, and I'm going to say my dog dot print all. Cool. There goes. Then just compare that. I'm going to say G++ inheritance. The CPP. I'm going to run that. Okay, so you have the kingdom is the vertebrate. The age is 11. The dash is flesh. Well, it hasn't printed anything for my dog. So I can remove this dot default constructor code and just say this kingdom is equal to kingdom. And to access those, I could put them under protected, all of them. Instead of making them private, I'd make them protected so that my class can have access to them. Cool. Now that error is gone. And that would be this food is equal to food. What else? This edge, the order doesn't matter. And I'll compile that and I run that. Right, sure. So you have two animals, the vertebrae, age is 2, the dash is chicken. But then notice I have more variables in my dog class than I have in my animal class. So that leads us to something we call polymorphism. I like this function to behave differently depending on what you're calling it. So I'll copy that function. It's the same function, it's just going to have different behaviors depending on which object is calling it, either an object of animal or an object of dog. So same function again, and I'm going to say here that oh, no, around the species is that's going to be species. Name is sorry, a slight disturbance. I stopped the video, but yeah, that's that. So it's talking about polymorphism, and that's that. Now let's run this. So I've made the same function is called print o. It's going to have different behaviors depending on which object calls it. So I'm going to run this. Right, so there goes. It has different behaviors depending on what's calling it. So in the first one, you can even print a space if you'd like to see that more clearly. You can print a space, I think, between the function calls. So you can print out the space. Alright, so this is the print of function. This is the animal class calling it, and it's only printing out three things. This is the dog class calling. Now the dog is inheriting from animal and it's printing out all these things. So this is called polymorphism. This function behaves differently. It's the same function called print or, but it behaves differently depending on what's calling it. That was that about um, polymorphism and inheritance.